Okay, as a pre-calc student, before we take a look at conic sections, I do want to go over a brief video on the intro to circles, specifically circle equations and how they relate to the radius, the center, the diameter, and to the graph. So right here on the screen is the basic formula for a circle. And you can see it starts with taking the radius, which is r, and squaring it, setting that equal to this quantity x minus h squared plus the quantity y minus k squared, where h and k are the center coordinates, and x and y will just sort of remain as x and y. And that translates, of course, to a circle on a graph. And this point h comma k in this case is going over 2 to the right and down 2 from the x-axis. So that tells us the coordinates of our center. So in this particular case, if I'm ever asked to determine what the center is, we usually call it capital C. It would be 2 comma 2, where h and k are both positive 2. The radius is the distance between the center and any point on the circle. So a number of different ways to calculate that. I'll go up here. So we have 1, 2, and 3. So the radius is 3. You can also do the same thing here, 1, 2, 3. Or same thing here, 1, 2, 3, or same thing here, 1, 2, 3. Technically this is 3 as well. A little bit tougher to figure those out though. So we'll put 3 as our radius. So the equation of this particular circle would be 3 squared is equal to x minus 2 quantity squared plus y minus 2 quantity squared. And you'll notice that if h is positive 2 in the actual equation, it says x minus 2. And it would be vice versa. If this were a minus 2 in the k, this would be a plus 2 down here in the equation. 3 squared is 9, as we know, so it's proper to simplify that out. But the other quantities here, they just kind of stay that way. So that's sort of the intro to the equation of circles. As pre-calc students, which you probably are if you're watching this playlist, you learn about circle equations back in probably geometry. So we'll get some more practice here. Again, this is leading up to our discussion of conic sections, which is a big part of pre-calc curriculum. But in order to get there, we need to first learn a little bit about circles. So here we go. Identify the center and radius of each and then sketch. So let's call the center point C and we'll call the radius lowercase r. The radius right here is not 9, but it's the square root of 9. Because remember, the radius gets squared to get that. The center is negative 4, positive 1. Remember, the format is x minus h quantity squared, so that means that if it's positive 4 down here, it's actually like saying positive is actually like saying x minus negative 4. So your actual h value is negative 4, and your k value, even though this is a negative, your k value is a positive. So it's just the opposite of what you see in the parentheses, basically. Alright, so let's plot our center. We're going to go left 4 and up 1. And we're going to count our radius of 3 from there. So I'm going to go right 1, 2, 3. I'm going to go up 1, 2, 3. I'm going to go left 1, 2, 3. I'm going to go down 1, 2, 3. And now's the tricky part. You just kind of have to connect the dots and just do your best. If you have a compass, that's great. I don't, so it's a little bit trickier for me. Pretty good. Number 2, we're going to use the information provided to write the equation of this circle. So we have a center of 1 comma negative 2. Remember, that's h comma k, and a radius of 4. So first thing I'm going to do is write my formula, my general format. That's my circle equation. And I'm just going to plug in my stuff. So I'm going to put x minus 1, quantity squared, y minus negative 2, quantity squared, is equal to 4 squared. And then just clean some of this up. That doesn't simplify. This I'm going to change to positive 2 squared, and this of course is 16. And you're done. Alright, here we have missing information. What on earth is our radius? Well, our radius is going to be, of course, the distance from the center to a point on the circle. So we have to calculate that first. In order to do that, we're going to simply find the distance. We're going to use our distance formula. Now, the distance formula is equal to a big square root, 2 little sets of parentheses in here, and we basically have our distance between our x's, so x sub 2 minus x sub 1, y sub 2 minus y sub 1. That's going to be our distance. In this case, the distance from our center to a point on the circle is our radius. So that's what we'll call our radius. And it might help you to graph this. I'm not going to, out of the sake of interest of time, but let's plug in these things and we'll see what we get. So let's call this x sub 1, y sub 1. Let's call this x sub 2, y sub 2, and just plug them in. So the big square root, x sub 2 is negative 4 minus negative 1, quantity squared, plus y sub 2 is 11 minus 9, and close it off. So this will give us our radius. Let's simplify. Negative 4 minus minus is plus, so that's negative 3. 11 minus 9 is 2. Simplify. Big square root. Negative 3 squared is 9. Plus 4. So we're talking about, in this case, the radius is the square root of 13. Now, that's not an integer, that's just a decimal. We're going to leave it like that, though. You don't want to use your calculators here. And here's why. Because when you go back to your circle equation, we have this as our circle equation. What you're actually going to do at the end is square that radius anyway. So if it's the square root of 13 squared, well, that doesn't, you don't need a calculator for that. That's just 13. So that's nice. It works out for us really well. And our center, let's see, x minus, let's cruise back up here and see what our center was. This, remember, this was h comma k. So it's x minus negative 1 quantity squared, y minus k quantity squared. And we'll just simplify that minus minus, and we're done. There we go. So that's how you write the equation of a circle when given the center and a point on the circle. We have to find the radius first and then plug it back into the original formula. Number 4. Look for the center first. We're just given a graph, so I can see visually that my center is right there. Our job is to write the equation of this circle based purely on what it looks like on a graph, on a coordinate plane. So my center is, let's see, I go left 2 and then down 4. Left 2, down 4. So my h comma k is negative 2 comma negative 4. My radius, of course, is going to be the distance from that center to any point on the circle. 1, 2, 3 units. So r is 3. And you just plug it in. So it's minus up here, we're going to put a plus down here. Same thing over here. 3 squared is 9. And you're done. Alright, number 5, we have, let's see, we're given a circle equation and we're asked whether these 3 points are on the circle, inside the circle, or outside the circle. So what I think I'm going to do is actually go to, I'm going to create a set of graph paper for myself and graph this thing. So let's see if I can get some graph going here. I'm going to make this a little bit smaller and delete some of this stuff. Alright. Let me get rid of this. Cool. So let's graph this. Let's go over here and we're going to put a coordinate system. And let's see if I can't make these straight. Yeah, it's not bad. And we'll put some lines on them. Some arrows. Okay, cool. So we have our coordinate system set up. It's always a good idea to graph whenever possible. Your center based on this equation is +5, -2. So 1, 2, 3, 4, 5, down 2. That's our center. Our radius is the square root of 16, which is 4. So it's going to be 4 to the left, 1, 2, 3, 4. 4 up, 1, 2, 3, 4. And 4 down, 1, 2, 3, 4. And 4 to the right. So what I did was I just moved my whole grid over here to give myself more room. So 1, 2, 3, 4. And just kind of connect them the best you can. Again, not super easy to do on the computer like this. In fact, I could probably do a little better job than that. Let's see. Let me do this. And the reason I'm graphing this is to answer this question a little bit easier. See if I can use the visual aid to help me determine whether these points are on, inside, or outside the circle. Then I'll go back and show you the algebraic way. So 9, -2. Let's see. Starting from the center again, we're going to go 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, -2. 9, -2 seems to be right there. So by visual inspection, that's on the circle. 3, 4. From the center again, always start from the actual center of your coordinate system. 3, 4. 1, 2, 3. 1, 2, 3, 4 will be up here somewhere. I would say that lies outside of our circle. 6, -3, +6. 1, 2, 3, 4, 5, 6. 1, 2, 3. And I would say that that lies inside of our circle. So that's kind of the visual way to determine these answers, right? It's sort of a shortcut, but you probably are going to be required by your teacher to use or to prove how to do these, how to do this stuff algebraically. So let's show some algebra here. Let's do letter A first. What you want to do is just plug that into your equation. So where you see a center, or rather a point, literally just plug that in for x and plug this in for y and see what happens. So here we go. Let's do 9 minus 5 quantity squared plus -2 plus 2 quantity squared, and you're really trying to determine if that equals 16. So we put a little question mark above that. 9 minus 5 is 4 squared. This is 0 squared. Does that equal 16? Well, 16 equals 16. That's true. So when left side equals right side, you can see that it lies on the circle. So that blue dot is literally on the circle. Let's try letter B. Again, plug in, letter B up here, plug in 3 for x. So we're going to go 3 minus 5 quantity squared plus 4 plus 2 quantity squared, does that equal 16? Well, this is negative 2 quantity squared plus 6 quantity squared, does that equal 16? Well, this is positive 4, this is 36. Clearly that does not equal 16. 40 is actually bigger than 16. When it's bigger than 16, when this whole, on the left-hand side with all the variables in it is bigger than the radius squared, that's when it lies outside the circle. And you can do that same process for letter C, and you'll see that the left-hand side is smaller than 16, which means it lies inside. Okay, last one here. What I want you to do here is pause it, see if you can fill in this chart, fill in all the missing spots right here. See if you can determine what the equation is for the first 3, and for the last 4, fill in all the missing pieces. Go ahead and pause and do that now. So here we go. Radius squared is 49 is equal to x minus 2 quantity squared plus y minus 10 quantity squared. Next up, the radius is 6, so we're going to square that. X plus 1 quantity squared, y minus 4 quantity squared. This is really good practice here. Radius is 11 squared, 121. Center is 0, 0. You can just write that like this. You don't need to put x plus or minus 0 or anything like that. You just write it like this. Whenever you see an equation that doesn't really have any parentheses, that means your center is at the origin. Moving on, we have the next one, number 4, I suppose it is. Number 4 has a radius of 9, which means this is 81. Seems that we have x minus 5, so our center, we need to fill that in. Our center is going to be positive 5 and positive 12. Again, it's opposite of what it is over here, the actual center coordinate. Here the radius squared is 144, which means the radius is the square root of that, which is 12. And here we have minus 1 and plus 8. Here we have r squared is 25, which means the square root of that is our radius, and our center is positive 9, negative 2. And last but not least, we have an r squared term of 100, so the radius is 10. X doesn't have a parenthesis, so that's just 0, negative 11. So there you go. That was your intro to circles, just a little refresher. Next up is going to be actually diving into all of our conic sections.